Hello friends, welcome to this video. My name is Sonali Jungale. Today we are going to prove a theorem of Riemann integration, and theorem is every continuous function is integrable. So let's start. Suppose we have a function f of x in closed interval a comma b, and since that the function is continuous and in a closed interval a comma b, this implies that function f of x is uniformly continuous function. Now, by the definition of uniform continuity, for any epsilon greater than 0, you will have delta such that modulus of f of x1 minus f of x2 less than epsilon, and provided mod of x1 minus x2 less than this delta, and here x1 and x2 belongs to this interval a comma b. Okay, now with the help of this information we have to show that f of x is Riemann integrable, and from the necessary and sufficient condition of Riemann integrability to prove f of x is Riemann integrable, we must have to show that UPF minus LPF, UPF is upper Riemann sum and LPF is lower Riemann sum, and is must be less than some positive value. Suppose that value is epsilon dash. So let's consider some partition P of this interval a comma b. So here P is partition of interval AB such that its norm is less than delta. Now we find UPF minus LPF is equals to summation of capital Mi minus small mi into delta xi. Now in any ith subinterval xi minus 1, this will be less than delta. Why so? Because norm of partition is less than delta. Okay, and since f of x is uniformly continuous, okay, so by the definition of uniformly continuity, I can say f of xi minus 1 less than epsilon, and we know that capital Mi is supremum of function f of x in this ith subinterval, and small mi is infimum of function in this interval. Okay, so it is obvious that f of xi and f of xi minus 1, this will be lie between capital Mi and small mi, and from the property of inequality I can say capital Mi minus small mi less than modulus of f of xi minus f of xi minus 1. Okay, now replacing this value with epsilon, we have modulus of capital Mi minus small mi is less than epsilon. We have u pf minus lpf is less than sigma epsilon del xi. Now taking this epsilon, so we have epsilon sigma into delta xi, and we know that total length of subinterval will be b minus a. So upf minus lpf, it will be less than epsilon b minus a. Okay, now consider another value epsilon dash greater than epsilon b minus a. Okay, now replacing this epsilon dash, so on replacing we have UPF minus LPF less than epsilon dash, and we have proved necessary and sufficient condition of Riemann integrability. Hence I can say f of x is Riemann integrable. Thank you. Thanks for watching.